Hello everyone. So in this question we are given an array A containing n integers and we have to count the number of ordered pairs which follow these conditions. Also, since it is an ordered pairs, so I comma j and j comma I are two different pairs, and again since there is no condition on I and j, so both I and j can be same also. That is, we have to also check whether I comma I is a valid pair or not. Also note that there can be cases such that both I comma j and j comma I are valid pairs, as you can see in the test case 3. Both 3 comma 5 and 5 comma 3 are valid pairs. Now let's see how to solve this question. First, let's see. It is given that the total number of test cases can be 10 to the power 5 and the value of n can be also 10 to the power 5. So the maximum time complexity will be 10 to the power 10, and to solve this large number, we have to write the program which solves the given problem in O of n. Okay, so first let's see how to solve this question in a brute force manner. So what we have to do, we have to select two indices I comma j, so and then we have to check whether this condition is true or not. So the brute force logic is quite simple. Just iterate over all the arrays. So make a two nested loop for I equals to 0 to n minus 1, for j equals to 0 to n minus 1, and check whether this condition is true or not. If this condition is true, then increment the count, and at the end just return the count variable. Here one more thing to notice that we will do j plus 1 and not j. Why? Because the question is considering the indices to be from 1 to n, that is, it's a 1 base indexing, and our array is 0 base indexing, so we need to do j plus 1. Okay, now how to reduce that? See, this outer loop will run for n times, and this inner loop will also run for n times. So the time complexity for this will be O of n square. It's not actually of n square. It will be more greater if you do this power operation. But let's for assume we are doing it in constant time. See, if we calculate power every time, so power can be calculated in log of n times. So it's actually O of n square and log f. So its time complexity is far greater than O of n. So this will give a clear error. Now how to reduce this time complexity? So we need to do two things. First, we need to efficiently calculate this power operation, and then we have to somehow reduce this operation to O of n. Let's see what can be. So the first thing to observe is that the AI is at max 10 to the power 9. So while calculating the power, so let's say AI was 5 and you did 5 to the power, and let's say n is 100, number of elements is 100, and you do 5 to the power 45. So if we calculate this, you'll see that it's actually far greater than 10 to the power 9. So approx around I think 25 or 27 this will hold, or maybe some value lesser. So when you did 5 to the power 27, you don't need to do the rest of the operations. Let's see what I mean by that. So we need to check for this condition. AI to the power j is less than or equal to aj. So let's call AI to be x and j to be j. Let's assume j to be y. So we have to check whether x to the power y is less than or equal to aj, and this aj is at max 10 to the power 9. Okay. Now here what we're trying to find is what's the maximum exponent, what's the maximum power that we need to calculate for each AI. Just hang around a bit and you will understand what I'm trying to say. So this aj is at max 10 to the power 9, so that means we have to check for this equality x to the power y is less than or equal to 10 to the power 9. Okay, so now both x and y are variable, so let's simply check for few initial values. Let's say x equals to 1. For x equals to 1, x to the power y will always be 1, and since we have to check whether ai to the power j is less than or equals to ag, and this is 1, and the minimum value of ag is 1, so this will always hold. So in this case, if your x is 1, then you don't need to iterate over all the elements, you just increment the answer by n. Why? So let's say you have 5 elements, this is 1, and let's say this is 2, 3, 4 and 5. So for this element, let's say this is your I. If this is y, then what can be j? So for j, you have either this 1, 2, 3, 4, 5 possibility. Why? Because the condition for I and j is it's this. So as I already told you, both I and j can be same also. So you have 5 possibilities for j, and since these since the minimum value of aj is 1, hence this equality will always see this x to the power y. So what is our x is 1, so if j is 1, it will be 1, if j is 2, it will be 2, if j is 3, it will be 3, if j is 4, this will be 4, if j is 5, this will be 5. So this will be always 1, and it is always gonna be less than equals to aj, because aj is always greater than equals to 1. So in this case, the valid pairs are, we have n valid pairs. So in this case, you have to increment the count by n. So if ai equals to 1, then we will do count plus equals to n. This is one observation. Now okay, this is one observation. If ai is 1, then just increment the count by n, and we don't need to iterate through every element. Now what's the other observation that we're trying to make? So we did x equals to 1. Now what about if x is 2? So if x is 2, then let's see 2 to the power 10 is 1024. So let's say we can assume it's around 10 to the power 3. Okay, now if we raise this to the power 3, then it will be also 3, so it will be 2 to the power 30 is approximately equal to 10 to the power 9. Okay, in fact 2 to the power 30 is greater than 10 to the power 9. Why? Because 2 to the power 10 is greater than 10 to the power 3. So if x equals to 2, you need to only check for 30 numbers, first 30 powers. So consider this example only, 1, 2, 3, 4, 5. Here your x is 2, so let's say this is I. So again your j will be 1, 2, 3, 4, 5. See, the maximum value of n can be 10 to the power 5, but we don't need to check for all these j's. So that is, j can vary from 1 to 10 to the power 5, but we don't need to check for this 10 to the power 5 element. We only need to check for 30. Okay, now what if x is 3? Obviously this will all decrease. Now since it's 2, so the power is 30. If we increase the base, if we make it 3, then 3 to the power x, if you find this value, let's say y, then this y will come out to be less than 30. So if these numbers grow for 4, 5, 6, 7, 8, this exponent will be less. So at max you have to check for 30 j's, not more than that. So here we are checking for all this, but no, we have to only check for j equals to 30 and not more than that. So here you can just do from j equals to 0 to j equals to 30, and since if we do this j equals to 30, it will be, so R2 loop will run for n times, inner loop will run for 30 times, so it will be over 30. But now what about this power? How to handle this power? So see, I'm just letting the inner loop for now. Let's do this n minus 1. You can also write 30 here. No problem. Third term, maybe let's say 31. And now what you have to do? You have to do, if ai to the power j plus 1 is less than or equals to aj, then we are doing count plus plus. Okay, but see, for the first time it will be ai to the power 0, then it will be ai to the power, sorry, it will be 1, then it will be 2, then it will be 3, and it's 4. So what's happening in every iteration? In every iteration we are multiplying the previous value by ai, so we don't need to calculate it again and again. So let's initially, this is the outer loop. Let's make a variable here. Let's call this variable power or temporary, anything, and let's call this ai. So this will be ai to the power for the first iteration, and before each iteration ends, so let's just do a temp into equals to ai, and we have to check, replace this with temp. So now this operation will be done in constant time O of 1 time, and these all operations are done in O of 1 time. So this loop will take O of 30 and the outer loop will take O of n. So our time complexity will be reduced by O of n times 30. And that's how we'll solve this question. So let me show you a sample code. So first I am just taking the input in the vector, then this is the, then I'm installing an answer variable which is count in the pseudocode, and if it's 1 then answer will be just n. If you even don't do this, with time complexity will not matter, it will remain the same. So as I told you, if ai equals 1, then the answer, then all the n value, all the n pairs are valid. So if ai equals to 1, you just add n, otherwise initialize the temp variable to be 1, and then you just multiply with ai in each iteration. See, it's going to n, but here I am adding a condition if temp is greater than 10 to the power n, just break it. So this break condition will execute at most in 30 iterations. Otherwise, if the condition holds, if this power is less than or equals to aj, then just increment the answer, and if you submit this, it will work. And that's all for this question.